When you solve linear equations for one variable, ultimately what you want to do is to get the variable by itself. So with the coefficient of +1. Now, when I look at this problem, one thing I want to make sure that I'm doing is I want to make sure I'm keeping my equal signs lined up. That's really important because there's some mistakes that you can make if you don't do that. So what I'd like to see you do is to draw this dashed line down through your equal signs to make sure they're lined up. On the ones we're doing now, they're not incredibly complex. So these are called one-step linear equations because there's one thing you're going to need to do to isolate the variable. When I look at the left side of the equation, the m is a variable term because variables look like letters, and the 8 is a constant. I don't want a variable term and a constant on the same side of the equation. So I look to the other side of the equation to see what's there. In this case, it's a constant, which means I want this constant of 8 to go over with the constant of 6. In order to do that, I see how the 8 is connected to the m. Since there's subtraction in front of the 8, it's a -8, I would add 8 to eliminate it on the left side. To keep this equation in balance, though, if I add 8 to the left side, I also have to add 8 to the right side. So I end up with m equals 14. Now if I want to check that, I go back into the original equation and substitute 14 where I see m, and take my calculator and punch in 14 minus 8 equals, and it should equal 6, which it does. In this case, I can look at this one of two ways, but if you have your calculator, probably the easiest way to look at this problem, first of all, we're going to put our dashed line down through our equal sign, if I can get this to work. Since the -4 is connected to the y with subtraction, and I see this, this constant on the other side, I want to move the -4 over there. To undo subtracting -4, I would add a -4. But if I add a -4 to the left, then I also have to add a -4 to the right to keep my equation in balance. I double check horizontally to see did I do the same thing to both sides of the equation, and I did, and vertically to see if I did what I intended to do. I intended to undo subtracting -4, and yes, it makes sense that I would undo subtracting -4 by adding -4. So I end up with the equation y equals -12 plus -4 is -16. And again, I can grab my calculator and punch in -16 minus -4 equals, and it does equal -12. Now there are some people who feel more comfortable in this problem rewriting the left side of the equation because they say, well, minus a negative is the same thing as plus a positive. So this equation really can be changed to y plus 4 equals -12. Again, you don't have to change the equation. Some people just like to do that. And then the way I would undo adding 4 to this side is to subtract 4 and subtract 4 from the other side. And I also get y equals -16 this way. Either way is perfectly acceptable. Now in this case, -6v really means, if I can get this to write correctly, -6 times v. When I don't see an operation between two things, there's multiplication in there. So the way, again, going to line up my equal signs, the way I undo multiplying the v by -6, because I want to isolate the v, is to divide by -6, because division is the inverse of multiplication. Double checking, -6 divided by -6 is +1 as the coefficient of my v, which is what I'm looking for. -45 divided by -6, I can punch that in my calculator. Negative divided by negative is a positive. 6 goes into 45 7½ times. Now, it's perfectly acceptable to write this as v equals 7.5 because it's an exact number. If I ended up with a problem that was something, say this instead, -8v equals -45 instead, then when I divide both sides by -8, v equals negative divided by negative is positive. 8 goes into 45 5 full times, and then there are 5/8 left over. So if I get this nice short little decimal that I can just write as a decimal, that's fine. If it's something longer that I would have to round, then I need to write it as a mixed number or a reduced fraction. Now this one looks a little bit different, but the concept is the same. A fraction bar means division, and I undo dividing with multiplying. So to undo dividing by -4 to isolate the m, I would multiply both sides by -4. Now I want you to rewrite the problem this way. Too many people get themselves in trouble if they don't rewrite this. So really what's happening here is the original problem is just rewritten down here, and then show that you're multiplying by -4 off on either side. So if multiplying by -4 undoes dividing by -4, the left side is just m, and then positive 12 times -4 is -48. So m equals -48. Now the reason it works this way on the right side, if I have m over -4, and I multiply that by -4, this is really -4 over 1. When I multiply fractions, I multiply straight across. So -4m over -4, and then since -4 divided by itself is +1, those cancel, leaving just the m. So that's why the left side works the way it does. Thank you.